Hey there, space weather enthusiasts. Welcome to another edition of the Daily Space Weather Show. It's exciting stuff going on. Only a minor uptick in solar activity, although the X-ray flux has come up. A mild increase in the sunspot number, and like we said yesterday, 3 coronal mass ejections headed in Earth's direction. Also, you may see some plasma instability happening in the northern hemisphere. That massive filament, let's zoom in a little bit closer, is looking like it is becoming unstable. So right in this area down here, it looks like it's breaking up, moving around, and so on. We'll talk about it and lots more on today's Daily Space Weather Show. The main feature at the Smash News Network least busted name. In news. These are 24-hour videos from Solar Dynamics Observatory, and we've got some spectacular footage of the closest star today. You might see also a crown prominence erupting just above the Earth scale there. That went on for hours and hours yesterday. And we did stream it. Again, we will show plenty of footage of the closest star and its latest antics. Here's a likely spot to see a large solar flare. That area could produce even an X-class event in the coming couple of days. Our regular viewers are well aware that sunspots are more likely to produce large flares as they approach the limb. Yeah, sunspots, they make big entrances and big exits. They tend to produce the largest flares when rising or when setting, or if they should happen to form right on the limb. You may see a dark feature right there crossing the center solar longitudes. That is a coronal hole feature. We can expect some increased solar wind from that. And again, like we said in yesterday's video, 3 coronal mass ejections to start arriving around midday on October 11th. So plenty of activity going on. Huge plasma filaments. You can see some up there in the northeastern limb. That would be the upper left of your screen. Multiple coronal mass ejections have erupted since yesterday. Again, we'll cover all of that. Some prominences happening down there in the southern hemisphere as well. So lots to cover today, including some fascinating cosmology stories. By the way, if you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/Smash Team. We launched our own subscription services site back in October of 2021 officially. And it's because we needed superior capabilities than Patreon had. So we still are on Patreon. I mean, you can get involved in all kinds of ways. We need your help to get the content onto screens. So press the share button, press like, subscribe, comment, press all the things because reasons, I shouldn't have to say this, but due to algorithmic nonsense, our views have been utter garbage in the past couple of days. Utter garbage. We were at like 3,000 to 4,000 views a day, and the numbers are just all over the place. It makes no sense, folks. I won't get into it, but smashomash.com/Smash Team is how to support the channel and get additional content from behind our paywall. The best value is the gold annual paid-up subscription. If you want to read about the actual plausible mechanism that underlies the solar sunspot cycles, join at the gold level. You can read all about my CRAPF. Yeah, my CRAPF theory, C-R-A-P-F. The paper's not submitted for peer review nor published yet, so only Gold Smash Team members get any insight into that. Congratulations on finding the world's most comprehensive daily space weather content and most detailed solar imagery. If you're new to the channel, press subscribe and do yourself a favor and get the most detailed solar imagery and space weather into your YouTube subscription feed, hopefully. But again, if you join the Smash Team, you'll get email alerts and you'll never miss a video like this one. So, many complaints about the videos not appearing in people's feeds. So we created solutions, although it's up to you to utilize those solutions, signing up for email alerts. So yeah, like I said, press all the things. And because we can't continue the video until you press all the things like Press the share button. If you're an influencer, drop me a line. Maybe I'll even appear in your channel. It's highly likely. I'm pretty agreeable when it comes to that kind of stuff. As space weather becomes more and more important, we didn't just jump on a bandwagon and align ourselves with space weather because it's a popular thing. It's because, well, I nearly majored in cosmology in mid-1990s. However, I didn't because I had to pursue pro sports, as there is a timeline for pro sports, but not for academic pursuits. So anyway, I'm back doing space weather. Support the channel via our paid affiliate/sponsor links as well. You can find them below the video, as well as links to the Smash team, the homepage, smashomash.com, and there is our Hemp Lucid shop. Save a ton on Focus Mushroom Gummies, also Immune Stacks, Stress Stacks, Sleep, Stress, and Immune Gummies. Massive savings there. Also, the lip balms are now back. Even CBD for your pets. Do your Hemp Lucid shopping via our shop and help support the channel that way, perhaps. Another paid affiliate/sponsor is our Amazon shop. So if you haven't checked that out, check out some of our shopping lists over there. Bulk spices, the coffee I'm currently drinking, and more. At amazon.com/shop/smashomash. Also linked below the video in the description. So what's this? I've heard some of you haven't pressed the like button yet, which means now I have to wait and wait for you to do that. So, Smash staff, are we detecting everybody having pressed the like button now, or? Oh, okay. She tells me you've all pressed the like button, which is lies. Lies, I tell you. By the way, save 20% on the merch shop. Yeah. You can now join the Croissant Earth Society and tell your friends and foes to stop believing NASA's lies about the Earth being an oblate spheroid. What are you, some kind of a maniac? You think the Earth is shaped like a sphere? Why would the Earth be shaped like a sphere when all other heavenly bodies are shaped like spheres? Obviously, Earth is shaped like the French breakfast pastry. Earth, it's croissant-shaped. What are you, an idiot? Didn't you know NASA was founded by Nazis? Yeah. Duh. Earth, it's croissant-shaped. Join the Croissant Earth Society and stop believing NASA's lies. What are you, some kind of cretin? God. The things people will believe. The good news, folks, is that Nibiru is going to pass right through this hole. So, that's the good thing. Nibiru is going to pass through the hole in the croissant, and it's not gonna crash into Earth after all. So, congratulations, you're not all going to die from Nibiru. Croissant Earth Society. Save 20% on all merch across the Redbubble shop. Let's get back to space. So, mostly stable here. No major changes in sunspots in the past 24 hours. Basically, the sunspots that we talked about yesterday are pretty much the same. That is October 8th and October 9th to date, SDO continuum. There is SDO magnetogram for the same period of time. Now we're going to take a brief moment to look at what's going on planet Earth. Volcanoes are first. We've got a pretty significant list here. Another lava flow there, cascading down the Sierra del Fuoco, part of the Strombolian complex, the most delicious sounding volcano in the world. Taal producing some low-level activity there, some unrest at the Philippine volcano Taal on the Isle of Luzon. Also Mount Mayon, much more active there. Unknown volcanic ash cloud. Please do not pole vault the caldera. So Mount Mayon, there are viscous lava flows and block and ash flows and pyroclastic flows, and it's pretty active there, Mount Mayon. Semeru also exploding, flight level 140 over East Java, Indonesia. It's a 14,000-foot ash plume. Dakono exploding. 6,000-foot ash plume over Halmahera, Indonesia. Sangay exploding. 22,000-foot ash plume over Ecuador. Riveridor exploding, flight level 150. That's located in Ecuador as well. By the way, it's a 15,000-foot ash plume. 25,000-foot ash plume over Peru from Sabancaya. and 21,000 foot ash plume over Ubinas. Also located in Peru, it's a flight level 210. And let's look at seismic activity. Major activity continues south of Japan. So we could be seeing foreshocks here, folks. So earthquake watch continues in the Western Pacific. Earthquake watch continues in the Western Pacific. Also, there was a 4.3 magnitude quake occurred in Washington. So we normally only talk about 5+ magnitude quakes. Let's go up the list here. Papua New Guinea had one of the largest quakes of the past 24 hours. It was a 5.9 at 18:07 Universal Time yesterday evening. And then a whole series of quakes here south of Japan continue, like a 5.0, a 4.8, a 4.9, a 5.0, a 5.3, a 5.1, a 5.4, a 4.9. Those all occurred between 2026 and 2121 Universal Time yesterday evening. So a whole series of quakes once again there. Could be a series of foreshocks, signaling the possibility of a larger quake. That 4.3 in Washington was at 2:21 Universal Time this morning. One of the larger quakes we've seen in Washington in quite some time. Indonesia had a 5.1 at 3:50 Universal Time this morning. That was at depth, over 120 kilometers estimated depth. 5.3 then strikes Russia. Looks like the northeastern portion of the Kamchatka Peninsula. At 5.3 was at 5:09 Universal Time this morning. And there you go. That's your earthquake rundown. And let's get back to space. Here we've got some more fresh imagery from SDO. That's 131 plus 171 angstroms, two different species of ionized iron. One of them is great at showing solar flares. That's the 131 angstroms. That is the hottest of the AIA wavelengths. The 171 angstroms is great at showing the quiet corona, the lower portion of the sun's atmosphere. It's the coolest of the AIA wavelengths. So that's another 24-hour video. And I would remind you, I said it earlier, I'll have to say it again. And there's the equatorial view, by the way. The past 24 hours from SDO. And I would remind you that that area right there is a very likely area to see a really strong solar flare, like an X-class event. And also I would note, look at this massive filament here that's just to the west of that huge sunspot. That is what we call a solar flare watch. Anyway, let's get to some stats here. The 10.7 centimeter radial flux has stagnated. It's currently at 157 solar flux units. And part of the reason why you see the radial flux moving at a different time than the sunspot number is because sunspots take longer to get measured. They take longer to get counted than the radial flux. The radial flux is a raw measurement of radial flux density. The sunspot number has to be counted. Sunspots have to be there for an extended period, 12 hours or longer. Anyway, there is the 1-year graph of the radial flux and the sunspot number. Radial flux is the black line, sunspot number is the red line. And that needs to be updated there. The sunspot number is actually at like 175, as we forecasted yesterday on yesterday's Daily Space Weather Show. Space Weather Enthusiast dashboard here, not forecasting any geomagnetic unrest or storms. So I guess NOAA didn't notice the 3 CMEs that are headed in Earth's direction. We did. So, yeah. So, NOAA, you should probably watch the videos. Also, NASA, since you've got people in space, you might want to tune into the Daily Space Weather Show. Just saying. I don't know. Whatever. Okay. Assets. You might want to cover your assets. See what I did there? Now, here's NOAA's forecast, and that is a forecast for a coronal hole high-speed wind stream, not for any CME impacts. So I don't know. I mean, what can you say? We're going to have 3 CME impacts that start to arrive around midday on the 11th. NOAA and NASA have no such thing in their forecasts. Now let's talk about major CME impacts, known as Miyake events, when the sun goes a little bit berserk and then basically creates solar-induced cosmic ray flux on planet Earth. Guess what? We just discovered the largest one ever discovered, about 10 times the power of the Carrington event. Yeah, about 10 times the impact level of the Carrington event. So about 14,300 years ago, a major Miyake event occurred, evidenced by tree rings in Switzerland, which is what this guy's digging up here on this riverbank. The largest CME event ever identified in tree rings. So that's the kind of event that would cost, I don't know, the article says it would cost billions. It would certainly cost trillions, as it would destroy satellites, probably destroy some power grids, the ones that don't shut down, and cause all kinds of other issues on planet Earth. Oh, I thought it was in Switzerland. It's in the French Alps. Okay, anyway. So some partially fossilized tree rings there have shown the radioactive isotopic signature of major CME impacts. Again, that one occurred about 14,300 years ago, and it was about 10 times the Carrington event. So that's an article from SciTech Daily. If you want to go read that yourself, scitechdaily.com is the source. Other Miyake events occurring at 993 AD and 774 AD. The one this guy's digging up is bigger than those. Let's take a look at Earth's magnetic moment from space for the past 4 hours. We have seen an uptick in the solar wind density, but not the solar wind speed. So that's the last 4 hours of Earth's magnetic moment from space. The space weather modeling framework depicts magnetohydrodynamic pressure. It's the Geospace Magnetosphere movie. We show it daily on the channel. And it is geomagnetically calm at the moment. Like we said in yesterday's daily space weather video and a few times already today, you can expect to see some geomagnetic storm conditions beginning midway through the day, universal time, on October 11th. Here's Earth's magnetic moment from the ground. Another 4-hour video. This depicts magnetic flux density at ground level. Magnetic flux density is measured in units called nanotesla. This is changes to Earth's B field, geospace delta B. Again, it is geomagnetically calm at the moment. Next, we'll look at the KP index, which is a global average of geomagnetism. KP index currently at 1.67. Again, it's geomagnetically calm, and let's move to the real-time solar wind data. So we did see a little uptick here. This looks like an early arrival of a coronal hole high-speed stream. Solar wind density made it up to about 25 protons per cubic centimeter, while the solar wind speed stayed completely flatlined here at barely over 300 kilometers a second. Now, there was an instrument changeover here, but that instrument changeover was right here. So we saw the solar wind density drop off drastically, going from 7.5 protons per cubic centimeter down to about 1.5 protons per cubic centimeter. So we may be seeing we're not seeing an uptick in the solar wind speed here yet, though. So, I mean, just a very minor one. Anyway, the current conditions are about 2 protons per cubic centimeter for solar wind density. Solar wind velocity here, only about 330 kilometers per second. Very slow and very diffuse. When we do see those CME impacts, you can expect them to create some major signals. And let's look at the GOES magnetometer next. There you go. There are the GOES magnetometers, the GOES 16 and GOES 18. Their magnetometers are located at about 23,500 miles of altitude, way out there in the outer portion of the outer Van Allen belt. And no major perturbations happening in their magnetometer readings. Another indication that no major space weather has been afoot, or ahead, or overhead, or whatever you want to say. Next, our top view ecliptic plane field plot, and there's a sector boundary crossing coming, folks. Oh no, please don't be spooked at sector boundary crossings. The solar plasma is polar. Earth is just about to move from a south pole current sheet to a north pole current sheet. Let's bring up the last image here. Let that play through one more time for you. And so there's the last image. Keep in mind that is over an hour old when we produced the video. And that sector boundary crossing to a North Pole current sheet will be coming probably before tomorrow's daily space weather video. So a new current sheet of North Pole orientation is about to arrive as a new moon approaches on the 15th of October. Maybe that means something to somebody. I don't know. If that affects your astrology forecasts, let us know in the comments. And here's our line of sight field plot. And here the sun's B field is depicted in blue, polar fields in green and red for north and south respectively, and the photosphere gong magnetism shown in grayscale. Again, North Pole current sheet approaching. And next, our line of sight coronal hole plot. We've got a well-defined coronal hole here that's going to provide an uptick in the solar wind density, followed by an uptick in the solar wind velocity in about 2 or 3 days. So that one might be arriving a little early, though, so we'll have to keep an eye on that. And when I say ion, well, pardon the pun. I mean, get it? See what I did there? Ions, charged particles. Particles that have extra electrons or are lacking electrons. Particles that aren't neutral. All right, enough of that. So there's our line of sight coronal hole plot. We do have North Pole coronal holes rotating in, but let's take a look at this South Pole coronal hole. There you go. That's the one that's going to be producing some geoaffectivity in the next couple of days. Right around the same time, we have coronal mass ejection impacts showing up. So that should make things interesting. That could create co-rotating regions. That's a well-defined coronal hole, and expect nothing but an uptick in coronal holes in the coming 2 years, because we've had a shortage of coronal holes throughout solar cycle 25 so far, and that shall not continue. So that is a well-defined coronal hole over here in the eastern limb. You can now see these getting more well-defined. These coronal holes over here are North Pole oriented. Sector boundary crossing is something like this. That's the past 24 hours in SDO 211 angstroms. The ultimate wavelength through which to view the ultra-important feature of coronal holes. Next, another rather important feature that people have been counting for hundreds of years, sunspots. And it rose just about to where we said it would rise to today. There you go. Sunspot number now at looks like about 177 there, according to Royal Observatory of Belgium. And you can expect this to flatten out now today because we don't see any new sunspot growth in the past 24 hours. It has been stable. So there's the situation. Again, likelihood of a large solar flare mainly up here in the northwest, but there are some flare players in the southern hemisphere as well. So 3454 and 3460. Also, we do see some activity around the eastern limb. So there are multiple spots, but again, the most likely place to see a large solar flare is certainly this area up here. There's not only magnetically complex sunspot up there setting near the limb, but there's also a massive plasma filament just to its west and north and south. So, and that filament is looking less and less stable, especially the northern portion of it as time goes on. Next, the past 24 hours in SDO continuum plus 94 angstroms. 94 angstroms highlights the active regions. SDO continuum shows sunspots. And let's subtract the 94 angstroms. That's ionized iron to just show the continuum. And that is what approximately 180 sunspots looks like. That's quite a few sunspots. And if you think we're already at solar maximum, think again. We're still like over a year out from solar maximum. All you have to do is look at the basic graphs to understand this. It doesn't require any in-depth analysis to understand why we aren't at solar maximum. It's something that an elementary school student could probably look at the graphs and understand, but for some reason, certain people keep claiming that we're at solar maximum. They've been saying it since January of 2023. I suspect it might be because they have no idea what they're talking about, and they have joined a cult which will remain unnamed. So let's move on to solar energetic particles and flares. No spikes in the ghost proton flux, but expect a spike in the ghost proton flux. This is an official forecast. You can expect to see a solar energetic particle event in the coming 2 days. There you go. There is an SEP forecast. The last time I did it, guess what happened? An SEP happened, a solar energetic particle event. So expect some equatorial and polar radio blackouts coming because of the high likelihood of solar flares, the magnetic channel connection between the sun and Earth at the moment, and anyway, there you go. An uptick in the X-ray flux has been going on as well. The background flux is now at about C1.56. So yeah, expect the sun to continue to ramp up for over a year because solar maximum has not been achieved yet. I can't believe it's controversial to say these facts, but apparently it is. And the channels that YouTube promotes, I don't get it. I don't get it, YouTube. What's up with that? Why do you promote such nonsensical crap on your platform? Oh, yeah. The largest flare of the past 24 just happened. It was a C7.62. And if you're wondering where it came from, so am I. Well, I'll be a monkey's uncle. Isn't that a surprise? It certainly looks like it came from the northwestern limb. Anyway, let's take a look at flaring for the past 24 hours. That's an SDO composite. That's the Solar Dynamics Observatory 94 plus 131 angstroms. And we're going to, before we talk about the insane CME that happened yesterday, let's take a brief moment to talk about what's going on overhead and basic cosmology stuff. You know, cosmology, it's where I came from in the first place. It's why I'm doing heliophysics, because cosmology is based on heliophysics. If there was a sudden revolution in heliophysics, it would sort of force a rewrite of all of cosmology. Anyway, Jupiter's setting in the west over Lehigh Valley, Pennsylvania right now. We've got a crescent moon and Venus up there high in the sky. Also Mercury being chased by the sun, being chased by Mars across the ecliptic. Also, interestingly enough, in the northeastern sky, in a couple of hours, watch this, 1 hour, 2 hours. In about 2 hours, Deneb is going to start sweeping across the horizon. There it is, just peaking up and then slowly rising. There's 3 hours. There's 4 hours as Deneb rises in the northeast. Deneb, the most important star in the entire Milky Way galaxy, and the brightest intrinsic object visible from Earth. It's jumping up and down saying, hey, look at me, I'm the only known cosmic ray point source, and hardly anybody knows anything about me, because reasons. So we're helping to reduce ignorance when it comes to astronomy, cosmology, heliophysics, astrophysics, and space weather, and even Earth weather, incidentally. But that's what's going on now over Lehigh Valley, Pennsylvania. Our star chart is from skyandtelescope.org. Next, our solar system forecast. Astrologers, now's your chance to make forecasts based on where planets are, because reasons. Anyway, here's your 1 week forecast as we approach the October new moon. Here's where things will be. On the 16th, we will have a crescent waxing moon, a tiny, tiny sliver appearing in the morning sky over Lehigh Valley, PA. The post-new moon phase, I just love it because I'm usually well-rested. New moon, it's my favorite phase. Let us know what your favorite phase of the moon is in the comments. Let's talk about accretion. Yeah, accretion. This is going to create controversy too, because this asteroid that's being studied here, a Kuiper belt object known as Arrokoth, Arrokoth. It sounds pretty demonic. Arrokoth. It looks like two bodies formed together. So the possibility that they formed like this, a rotating cloud of small icy or rocky bodies, perhaps coalesce in the outer solar system. Eventually you have two objects which are now orbiting each other, getting closer and closer on a collision course, and eventually they touch and form one rotating object. Why do we think that's a thing? Because the two objects are really different. Those two space rocks look like they're probably separate things that have sort of connected as a result of gravitational accretion. Yeah, they look very differently. In other words, the color and the shear properties and so on associated with those space rocks, very different. An indication that they were probably formed in slightly different areas and sort of came together. Two piles of rocks. So yeah, two piles of rocks. This article here from another one from SciTech Daily. Mound Mysteries in the Kuiper Belt. The shared origin of Arrokoth's giant structures. So that thing's about 20 kilometers in length. A great dumbbell-shaped object. Again, that article's on SciTech Daily. 5-kilometer mounds dominate the appearance of the larger lobe of the Kuiper Belt object. And there it is. Two very different large rocks, possibly both formed from piles of rocks. The old accreting piles of rocks idea of how things might form. I guess that'll be controversial too to some people who think everything's electric, and people who don't think that electric universe is pseudoscience. It's pseudoscience. Anyway, today's astronomy photo of the day is a rising annular eclipse. So that's a distorted rising annular eclipse caused by heat distorting the path of light in Earth's atmosphere. apod.nasa.gov if you want to view the astronomy photo of the day. It's always great. And one more article here, another interesting cosmology article. We've got two galaxies that are really different in all kinds of different ways. So first of all, and I don't remember the name of it, but these galaxies are very close together. So they're like a couple 100 million light years away, and that elliptical galaxy right there is what we call a liner, which is a low ionization nuclear emission galaxy, which means it's full of neutral material. It's not very ionized. Hence, low ionization nuclear emissions. In other words, it doesn't have that much plasma. It's got a lot of neutral material. Now this galaxy here, which is only about 150,000 light years away from it, that one is more normal. It's got lots of ionized material like most galaxies do. What makes this galaxy interesting is that it has so much neutral material. Again, known as a liner, L-I-N-E-R galaxy. So that's an interesting one. One of the theories is that it's consumed some other galaxies, and this is in a huge galaxy cluster known as Able 1185. Another article on SciTech Daily. Those two galaxies are certainly gravitationally interacting. Again, they're only 150,000 light years apart. That's like the Milky Way galaxy would, fit in this area, but just barely. So it's an interesting one. The galaxies, the liner galaxy is NGC 3558, and the one in the upper right is Leda 83465. That imagery from the Hubble Space Telescope. Another article there on SciTech Daily if you want to read about interacting galaxies. And let's talk about coronal mass ejections, since we've had a pretty spectacular series of days here. Here are yesterday's CMEs. And if you want to see those in more detail, watch yesterday's daily space weather video, since we do some analysis of the earlier ones. The rest of those are not earthly directed, at least according to all the information I see. So you might see that spectacular one coming out of the north, and there's another one out of the southwest. Anyway, that's 100 frames from yesterday, October 8th. And here are an additional 38 frames from today, October 9th. Some more CMEs there. Again, we do not anticipate those to be earthly directed. So 3 are on the way. Expect them to arrive on the 11th of October, about midway through the day, Universal Time. Besides that, no new CMEs in an earthly directed trajectory. So here's Soho Lasco C2 and C3 together. There's that spectacular CME coming out of the northern hemisphere. And there's one coming out of the northeast earlier this morning. This does show time and date stamps down in the lower left. If you're wondering when those events occurred, they are slightly separate there. The C2 is ahead of the C3. We'll also show stereo A. Stereo A located right here, just ahead of Earth, orbitally speaking. Seeing space weather that's a little to the west of Earth. There's stereo A's coronagraph on the left and the difference imagery on the right. We'll let those play through for one full run also. Ah, yes. Coronagraphs. So there's that spectacular CME produced by the Crown Prominence, which we streamed throughout the day yesterday. We had to adjust our field of view because it was so massive. And here it is. This is the GOES-R. That is the GOES-R plus the SDO, both in 304 angstroms ionized helium. So you're going to see that Crown Prominence make its way out right there. And that is a 24-hour video, so it's, it's moving kind of fast. We've also got a zoom in of that. And then we're going to show you some even more detailed imagery of that CME. So, whoops, there it goes. And again, this filament to the south of the Earth scale is becoming unstable. It is unstable right now. And there is some significant movement happening around there in the northwestern limb of the closest star. And now we're going to cut to the Twitch feed. Yeah, the Twitch feed, because yesterday we streamed it. And again, we had to change the field of view because it was so extreme. So here is the Twitch feed. And that CME started to jump off around 1600. So there is the initial portion of that, and it took a long, long time to make its way out. It really took its time there. Also, other events there happening simultaneously in the southwestern limb. A CME and plasma filament reorientation and collapse all happening there at once. Move that ahead a little bit. There it goes. And those more recent CMEs, again, those are not earthly directed. Here's some proof of that. There's that one out of the southwestern limb. There's also one out of the northeastern limb. Let's see here. There's the one out of the northeastern limb. There was an ill-timed lunar eclipse from the GO-16's perspective there. And that's why you can see that partial obscuration happening there around the same time as that CME happened in the northeast. Again, those are not earthly directed CMEs. And let's move on to filaments. We don't want the video to be too lengthy, but there was a lot of activity to cover today. So here's the El Teide, Spain, ground-based solar observatory. And yowzers, look at the filament fest as it continues. Of course, this one here is absolutely berserk. This one's huge, 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 huge. And there's one over here that's quite massive as well. Massive filaments right now. Likelihood of coronal mass ejections moving forward is 100%. There's all kinds of plasma instability happening, so them's the facts. Here's a grayscale image. We show it because it shows prominences. It's not as cool looking as the colored one, but it does show prominences. And there are a ton of prominences around the western limb, as you can see. Here's the most recent plasma. Oh, and by the way, if you want to name filaments after living people, do it over on Twitter. Yeah, Twitter. x.com/smashomash, x.com/smashomash. And if you've unplugged entirely from social media, we don't blame you. It is pathetic. The censorship is pathetic. And if you think censorship is fixed on Twitter, you are living in a delusional cult-based fantasy, which is also pathetic. x.com/smashomash. Thanks to our new followers over there. So here's that instability I was telling you about, and dag, that is a massive filament. So eyes on this area right up here. There is a lot going on, and eyes on this sunspot right here. The likelihood of large solar flares is strong. That's the past about 2.5 hours from the GO-16 SUVI, which is, by the way, streaming on the Twitch channel and on the Smash Team site at smashomash.com/smashteam. So that's interesting, and that brings us to bonus features. We ain't got no charging hazards. Satellite charging hazards here are non-existent. It's smooth sailing for satellites, according to the Satellites Community Dashboard. The GOES electron flux is at a little lower level than we saw. A little bit lower levels than it was yesterday around this time, which is just after midnight local time for the GOES-18, evidenced by that red M. That's midnight local time for the GOES-18. Here's the one-year graph from Solon.info. Did you know you can actually follow coronal holes over on Solon.info? Yeah, fascinating information over there. Solon.info/solar. Here is the greater than or equal to 2 mega electron volt electron flux forecast by NOAA. And I would expect those levels to be a little bit lower in 2 days when the CMEs start to arrive. So I don't know how NOAA missed all those CMEs. They only missed 3 of them. No big deal. By the way, the first one's likely to be a KP less than a KP6. The second one's not likely to be much over a KP5. And the third one is likely to be possibly even KP6 plus. So some geomagnetic storms likely on the way. NOAA's forecast there, no. These are going to be lower when those CMEs arrive. But there's also a coronal hole high-speed stream, so that's going to further lower the electron flux. That's my forecast. Next, we'll show the layer where it's measured using radiography, the F layer of the ionosphere. And here is the vibrational frequency of the ionosphere. It's shown daily on the channel, and we're seeing very high frequency ionosphere at the moment. And that is what happens when you see no space weather for an extended period of time. So it looks a lot like solar minimum ionosphere. Not a lot of scintillation happening there. But there's some coming. 3 CMEs and a coronal hole high-speed stream. If that was Greek to you, here's the anomalygram. That depicts anomaly in megahertz from a 30-day median. You'll see lots of blue there. Lots of blue. Those are high-frequency ionosphere anomalies. There's the latest image. It's 1300 universal time for the ionogram, and there's 1300 universal time anomalygram. We also show the Ionosphere nowcast. It shows total electron content as well as maximum usable frequency. This section of the video is good for radio and GPS operators. The left is going to show you the most likely place for GPS errors, and the right is going to show you maximum usable frequency for your radio usage. The Global Ionosphere Nowcast. Today we're going to skip a section, but we are going to show total electron content over North America. We're going to skip this section because this looks like utter nonsense. There's no way the electron content is actually that low. So let's just get rid of this total electron content forecast page entirely. There's no way that's correct. Here's the total electron content anomaly over North America, and this looks like it's accurate. So there you go. There's the anomaly from the 10-day average for total electron content. It's free electrons to about 12,500 miles of altitude, the inner portion of the outer Van Allen belt, which is where your GPS satellite's located. Some significant signals there around the Pacific Northwest, actually. We'll close out space weather with the latest high-res imagery. And again, the most important spot to watch is right up here. It is a Beta Gamma Delta class sunspot approaching the limb with a massive plasma filament all around it, both to its north and to its northwest, especially. That is a place to expect to see a large solar flare, including a possible X-class flare event. Expect radio blackouts, both at the equatorial and polar regions. The polar regions will be caused by a solar energetic particle event. Them's the facts, folks. Them's the facts. So there's your magnetogram and continuum. And it's time to move to meteorology. By the way, if you haven't pressed the like button, now you have to wait again. You tuned in the middle of the video and now you haven't pressed the like button. What the heck? Oh, yes. Oh, yes. Now we're looking at the world's lowest pressure. So this is mean sea level pressure and surface winds. Of course, those things are correlated. You know, like hurricanes. Hurricanes, they're associated with high wind and low pressure. Interestingly enough, high winds are associated with high pressure as well for a completely different reason. Why? Because low pressures suck and high pressures blow. As you can see, there's air moving into the center of this. And check out this high pressure region. There's air moving out of the center of it. High pressures blow. They're like a pressure, like a pressing down on the atmosphere. And low pressures are like a pulling up of the atmosphere. Anyway, those are the lowest pressures in the northern hemisphere. But the world's real lowest pressures are in the Southern Ocean. Check it out. It is stormy seas down there, folks. Dag. 934 hectopascals is hurricane force low pressure, but since the air is cold, it's not holding that much moisture. So that is quite a stormy scenario around the Southern Ocean. The world's lowest pressure there is off the coast of Antarctica. Anyway, we like to show different features here daily on the meteorology segment because we like when our viewers understand atmospheric physics. That way, we empower them to do stuff like forecast their own weather. I know, so controversial, right? Anyway, let's move to the surface wind environment for the eastern world. Shout out to our viewers from all around the planet. If you're viewing the video from a different timeline, plane of existence, universe, multiverse, galaxy, planet, spaceship, etc., make sure you leave us a comment and identify that location or timeline or plane of existence. These are the jet streams. Since we showed the surface winds, there are the jet streams of the east. Here are the jet streams of the central world. Here are the surface winds of the central world. Here is a location of the most strife that people are talking about. Here are the surface winds of the west. And let's don't forget the jet streams. So we still have a jet stream convergence happening here over the western world. And a huge low just loitering over eastern Canada. So, and it's bringing snow, and it's going to continue to snow. Look at that. That's the forecast for the GFS model all the way into Wednesday. Yeah, Wednesday, it's still going to be snowing. It's going to snow all throughout the day Wednesday in some areas of Canada. At least according to the GFS model. The Euro model looks like it will turn to rain earlier based on the Euro model. So there you go. That's a forecast for precipitation type. And let's just look at new snow. So there's the 3-day forecast for new snow based on the Euro model. And there's the 3-day new snow forecast based on a GFS model. The GFS model forecasting a lot more snow there. So colder temperatures in the GFS model than the Euro model. Also some snow coming to the Rockies, despite all the hot air coming out of Colorado. Next, clouds and fog over the Americas. And let's speed this thing up and get this video under an hour. It's going to be close. There is clouds and fog. Here's a close-up of this loitering low. It's a loitering low. Shout out to all our Canadian viewers. There are plenty of them. That's what's going on. That's shortwave radiation from the NASA GOES Interactive Weather Satellite Suite. Next, our forecasts, starting out with our weather.gov page, weather.gov. If your county or seaway is lit, click it on the map at weather.gov. A bunch of freeze and frost warnings there in places like North Carolina, as well as Michigan, Iowa, Illinois, and Minnesota. Here come some forecasts. The jet stream, it controls your weather, unlike mankind. There are the jet streams. And we'll have warmer weather coming to the southeastern U.S. in the coming days here as the jet stream moves to the north. 72-hour GFS jet stream forecast, 250 millibar winds. Here's the GFS 72-hour pressure and precipitation forecast. Some heavy rains coming to the Gulf Coast. Here's your 72-hour GFS total positive accumulated snow depth change in inches. So not that much more snow coming, but it's just going to keep snowing for an extended period. It'll be light snow mixed with mostly rain. So wet, smelly, slushy snow coming to Canada. Last but not least, it's your GFS 72-hour temperature anomaly forecast in degrees Celsius. I won't try to explain the map. I'll just move on to our lightning mapper. There you go. There's lightning. And here's our real-time lightning map. It looks like the lightning's been coming back, folks. Lightningmaps.org now reporting all the way up to 80 strikes per minute. We were seeing really low lightning counts for the past couple of days. Now a little bit more lightning on the global map. Still kind of low though. Once again, if you enjoy the content, support the channel. Visit our links, like smashomash.com. You can find our links there. The Redbubble Shop, again, 20% off everything at the Redbubble Shop. Massive savings at the Hemp Lucid Shop. Massive savings on things like spices and coffee and all kinds of stuff at the Amazon Shop. Check it out. Support the channel. Cheers. Press like, subscribe, share. We'll close out the video with the latest U.S. Doppler radar. There is the full 50-state view. There's the lower 48 view. That's the Doppler radar. Here is clouds and fog. And there is water vapor. You can see that jet stream convergence happening via the water vapor map. Here's your recap. And hopefully you're not viewing real crap on YouTube. Anyway, once again, congratulations on realizing the channel exists to our new subscribers. And yeah, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And in the meantime, may that solar wind be at your back.